we're Team7, and we're presenting our findings in the topic evaluating testing and debugging tools on real-world bugs. And firstly, I want to present the findings in defects4j. It's relatively easy to generate runnable test files using Redupe and EvoSuite compared to other datasets. And also, those bugs that can generate the runnable test files are low in LD. And that means those bugs is with desk modification. So Redupe and EvoSuite can easier to find those bugs.
Okay, let's talk about another dataset, QuickBooks. This dataset includes 40 unique programs derived from the QuickC challenge, translated into both Python and Java, providing a rich source for evaluating our testing tools. In our analysis, we observed that the QuickBooks dataset had relatively low LD and CodeBlue scores, which means that the bugs presents are generally simpler compared to other datasets. Furthermore, our findings show that bug localizations measured by average rank and first rank is quite effective for the randomly selected samples within this dataset.
Okay, so the next dataset is Bears dataset. It is a bug dataset designed for Java 8, and it is collected from some open source projects available on GitHub. So during the project, we have some findings. First, it is hard to use EvoSuite to generate an error revealing test on the Bears dataset. Second, it has a relatively higher average rank than other datasets. This indicates that during the debugging stage, we still cannot ignore the statements with low suspiciousness score.
Okay, so this is my findings for Bugswarm. Bugswarm is also a project collected from open source GitHub files, and it's comprised of Java and Python projects. And the test for bugs is 0 to 4, which is relatively low. And from the coverage, we can see that some statements aren't even covered by tests at all. So this suggests that there are insufficient tests for this bug. And another finding is that the bugs in this code has a higher average CodeBlue value. So this suggests a better generated test, both syntactically and semantically.
Okay, so here are some evaluation of our findings. And for class changes, you can see that majority of fixes involve few class modifications, suggesting localized bug fixes. And for method changes, greater variability indicates diverse bug complexity at the method level. Some bugs require extensive changes, while others need minimal adjustments. And for line changes, reflects the depth of code alterations necessary. Extensive changes suggest complicated bug fixes. Okay. And for CodeBlue and LD, we can see that tests that closely resemble original tests, which is low LD and high CodeBlue, indicate good detection of simpler bugs. Variabilities in these metrics for undetected bugs suggests the need for tools to handle complex scenario better. Okay.
Okay, so this is the results of our bug localization. So from the relationship between the rankings and LD, it shows little correlations. However, we can absorb that from the CodeBlue and the rankings that there are some negative relationships. And this actually makes a lot of sense because a potential buggy code has a lower CodeBlue, suggesting the code quality is lower.
And finally, let's come to our conclusion. So both Redupe and EvoSuite show the strong capabilities in generating tests that effectively detect and localize similar bugs. However, there are struggles with complex bugs due to variation in test generation and metrics.